Hello. So, hello everyone. Welcome to the week 11 tutorial of digital circuits, NPTEL, that is offered by Professor Shantanu Chattopadhyay from IIT Kharagpur. Myself, Sai Shubham. I am pursuing my PhD in the Department of Electrical Engineering from IIT Gandhinagar. So, we will start with the week 11 questions. This is related to 8085 microprocessor. Fine. So, the first question is that in Intel 8085 microprocessor, the ALE signal is made high to options are to fetch the instruction, to increment the program counter, C. Enable the data bus to be used as a higher order address bus, D. Enable the data bus to be used as a lower order address bus. Okay, so I will give you a couple of minutes to solve this question. So I hope my voice is audible. Let me check again. Hello. So let's solve this question. So ALE signal. Let's look at the answer. So this is your 8085 microprocessor, and here you have the ALE signal. This signal goes into a latch. Okay. So here you have 16-bit address, right? And this bus that you see is used for bidirection data lines. This is used for getting the data as well as storing the data. So once you give a particular address from where it fetches the data, now for a reference, you have to store the data, right? So ALE latch is used to save the address so that this can be used later to store the data. Fine. Moving on to the next question. The clock speed of the 8085. The next question. The clock speed of the 8085 is is. So 10 megahertz, 2.5 terahertz, 8 megahertz, and 3.125 megahertz. So this is a memory based question. The answer is that the range of clock speed can vary from 3 megahertz to 6 megahertz in different configuration of the 808 microprocessor. Typically, the internal clock that is there is of 3.125 megahertz, whereas externally it can be 6.25 megahertz. So moving on to the next question. The CMA instruction, what does it do? A. Decrement the contents of the accumulator. B. Performs 1s complement of the accumulator contents. C. Increment the contents of the accumulator. D. Performs 2s complement of the accumulator. So the CMA instruction, what it does is that it basically takes one is complement of the content of the accumulator, right? For example, if you have any data stored 0030H, it will convert it to FFCFH. So what does one complement means? It means that if your number is like this, what will do? It will do bitwise. It will do bitwise flip operation. It will take bitwise complement. So the complement will be 1001. So this was 1, and this is 6. So this is 16H, and its complement is, I think this is E, and this is 9. So E9. And when you add these two numbers, it will always be FF. Okay. If you add these two numbers, this will be FF. Okay. So that's what CMA instruction does. Moving on to the next question. The content of the accumulator register in 8085 microprocessor contains 4EH after an arithmetic operation. What will be the status of the parity flag? So it is set, reset, don't care, and high Z state. So a hint I would like to give is that in parity condition, what we check is that we check the number of ones present in the in our content, in our data. If it is even, then your parity flag is 1. If it is odd, then the parity flag is 0. So I think this question can be done. So the answer is, if you look at here, for E, so in 4, 4 can be represented in binary as 0100. So it has 1, and E can be represented as 1110. So there are 3 ones. So in total, there are 4 ones, which is an even number. Therefore, the set flag is, therefore the parity flag is set to 1. That is, it is set. Okay. If had it been odd, it would be 0. So it would be called as a reset condition. Moving on to the next question. In an 8085 processor, suppose the accumulator content is 0fh and the carry flag is 0. What will be the content of the accumulator after RAR and RRC instruction? So both cases, content of the accumulator is 87h. Both cases, contents of the accumulator is 07h. RAR is 07h, RRC is 87h, and RAR is 87h, and RRC is 07h. So I will give you 5 minutes to solve this question. So let's look at the solution right now. So it says that the accumulated content is 0FH. H represents that the data is in hexadecimal. Okay, so the content is 0F. Now the carry flag is 0. So what do we have here? 0FH. It is 0 0 0 0 F 1 1 1 and 1, and carry flag content is 0. Another case, this is 0 0 0 0 1 1 1 1. Okay, so what will happen over here? So this one will go into carry, and carry content will come over here, and there will be a left shift. So this content will be 0 0 0 0 0 1 1 1. This is 0 7. In this case, what will happen? The content will go into carry, and the content will come over here 1 0 0 0, and it will be 0 1 1 1. So it will be 7, and it is 8. So 87. So answer is 0 7 and 87. So 0 7 and 87. So answer is C. Moving on to the next question. How is the data accessed in 8085 stack memory? Okay. The options are LIFO, FILO, FIFO, and LILO. So L stands for last, F stands for first, I is for input, and O is output. So LIFO stands for last in, first out. So the answer is LIFO. It operates like this. You push some data in the stack. The next data goes in the second position and in the third position like this. But when you have to retrieve the data, the memory address present is in the last one, right? So this data will first come out. This will come out next, and this is the last one. So entry is like 1 2 3. Exit is like 3 2 1 in the opposite order. Okay, so this is your last in, first out. Last in, first out. So this data went in last, but it came out first. Okay. So moving on to the next question. How many T states are required to execute the following function? LXI D 1 2 3 4 H. So let's look at the solution. So what do you have here? LXI 0. I think it's supposed to be B 1234H. So this is the data that we need to store. Okay, and we need to store in the register B. Since this is a 16-bit data. Okay, and the registers that we have are of 8 bits. So whenever we call this function LXIB, so it is implied that BC as a register pair is used. Okay, so this opcode, in order to read the opcode, 4 clock cycles are required. In order to load the lower byte, 3 clock cycles are required, and in order to load the upper 8 bits, 3 more cycles are required. So in the end, the total number of cycles are 4 plus 3 plus 3, which are 10 clock cycles. So the answer is 10 T states. Moving on to the next question. Which of the following is an 8-bit register in 8085 microprocessor? So as we have discussed just now, B is a 8-bit register, but BC as a register pair is of 16 bits. Right? Stack pointer is of 16 bits. Program counter is also of 16 bits, and the accumulator is of 8 bits. Okay. So D is the answer. Moving on to the next question. Which of the following register is non-programmable? So in the previous question, whenever we deal with the data, it is generally 8-bit, and whenever we deal with the address of the data, it is generally 16-bit. So program counter, basically what it does is that it points out to the address of the instructions that has to be executed. Okay, so it contains the location of the address. So that's why it is 16-bit. Stack pointer, similar purpose. BC is a register pair, that's why it's a 16-bit. And accumulator, because our data that we generally deal with is of 8 bits. Okay. So the register that is non-programmable is the IR register, which is your instruction register. So what is an I register? It is basically a temporary register that stores the instruction that needs to be executed, right? So A, B, H, this we can program, but IR we cannot do it. Moving on to the next question. Which of the following register pairs holds the memory location address for the instruction MOV, move, M, B? So options are BC, HL, D, and SP. SP is the stack pointer. So the answer is, so let's discuss the solution. The M refers to the memory location pointed by H and L. Therefore, the contents of B is transferred to the memory location pointed by HL register pair. Okay. So M is represented by the memory pointed by the H and L. Okay. So we have couple of general purpose registers. One is the accumulator, another is register B, register C, which form a register pair. Then we have D and E also. Individually, they are 8 bits, which can also be operated independently, but we can operate them together using a 16-bit D register pair. Now we also have H and L, which are special because they act as a memory address. Fine. So these are our general purpose registers, including the accumulator. Moving on to the next question. This is a good question. How many times ORA B instruction will be executed in the following program? Okay. So I think everyone should give it a try. Okay, so let's discuss the solution right now. I think I have given enough time for you to solve. So here is the kind of solution right now. The question asks how many times the instruction ORAB will be executed. So ORAB is basically the bitwise OR operation that has to be performed between the registers B and accumulator A. Okay. So now here you have set some value in B. Now this is basically your BC pair. Fine. So what we have is that we are decrementing B. Okay. So here there is a difference. You can see that DCRB means that whatever content that is present in B, we are subtracting by -1. Whereas DCXB means that whatever content that is present in BC register as a whole has to be subtracted by 1. Okay. So here we have 0010H, that is in decimal it will be 16. Now contents of C is moved to accumulator A. Okay, so here we have content 16 that is moved to accumulator A. Now we are performing OR operation with B. So here B is 00H and A has content 10H. So if you perform OR operation, it will definitely be 10H only. Fine. And next, here is a jump not zero condition. So whenever your accumulator is not 0, it will jump to the label that is loop. So it will jump back again here, and the same instruction will be performed in iterations. Fine. So here you are decrementing B. So accumulator can go to 0 when the content of BC is 0, and the content of BC is right now is 16. So it will take 16 iterations for it to get to 0. So the answer is C. So moving on to the next question, what is the total delay produced by the following group of instruction assuming clock frequency is 2 megahertz? Okay. So let's discuss the solution right now. So MVI, there are a couple of instructions. MVI, move immediate, DCR, decrement, J and Z, that is jump if not zero. Okay. So here we have to look at that MVI has 7 T states. Okay. So if the frequency of the clock is 2 megahertz, then each T state will have 0.4 microseconds. Fine. And FF is basically 255. If we convert it into decimal, FFH is basically 255 in decimal. Now, move immediate C will take 7 states, 7 cycles. And there is a loop, right? In the loop, what will happen? This decrement will have 4 cycles and jump will have 10 cycles. Now, this jump will happen for how many cycles? It will happen for about 255 cycles because the FF has to decrease from the contents of the register C has to decrease from 255 to 0. So there are 255 iterations. Fine. So 70 is the first cycle, 7 cycles in the beginning. Then you have 4 cycles and 10 cycles in every loop. And this will repeat for 255 cycles. So the total number of cycles will be 255 into 14 cycles plus 7 cycles. So this will come out to be 1.7885 milliseconds. So answer is the answer is A. Okay. Moving on to the next question. What is the minimum number of cycles required for a simple move instruction in 8085 microprocessor? So the minimum can happen when your contents have to be shifted from any register B to your accumulator A. That takes about 4 cycles. So this is the answer. Next question. In a timing diagram, the right signal is typically active during the which phase of 8085 microprocessor operation? So it is basically T2. That you will have to check from the waveform diagram. The last question. Which addressing mode is used in instruction LDA4321 in 8085 microprocessor? So let's look at different addressing modes. We have implied. Implied means that we are talking about the accumulator only. Fine. Next we have immediate. So move immediate B. What content has to be moved? 45H that we additionally provide. So this is your immediate case. Now we have direct. In direct, what we do is that we directly provide the address of the location where we need to store the contents of the accumulator. Fine. And in the indirect, what we do is that instead of directly providing the address, we store the address in register pair, that is BCDE or HL, and we give the name of the register where the address is saved. Okay. So here you can see this is the indirect referencing. Fine. So as you can see in the question LDA4321, this is a what? Direct addressing mode. So the answer is C. So that's all for today's tutorial. In the next tutorial, 8085 will still be discussed, and some of the instructions we will see. So I'm stopping the recording right now. If you have more questions, let me know.